Hello friends, hope you all are doing well. Today we are here to present our project based on Ethereum blockchain technology, which is in boom these days. We have developed an application, Decentralized DigiCerts, which allows direct exchange of digitally signed documents such as academic certificates, professional certifications, and government documents without an intermediary like notary requiring to authorize the signer. How do we do this? Well, we make blockchain as the notary. When the digital document is signed, it's added to the blockchain, and the receiver or verifier can access the blockchain to ensure the authenticity and integrity of the document. To demonstrate the feasibility of this solution, we have implemented one application of this technology, which is in the education sector. Higher education has faced long-standing problem of fake academic certificates. There is no efficient technical approach to protecting authentic qualifications so far. Let's see how decentralized DigiCerts helps to solve this problem. This diagram depicts the overall workflow of the decentralized DigiCert system. Let's say Jenny wants to request her digitally signed certificate. She'll ask her institution to issue her the certificate. The issuing institution uses decentralized DigiCert software to issue the certificate. In a nutshell, what the software does is the following. It creates a certificate for Jenny, computes a SHA-3 for the certificate, signs it using its private key, adds signature that is signed hash along with the Jenny's public key into the Ethereum blockchain, sends the certificate to Jenny, which has embedded functionality to verify the authenticity and integrity of the certificate by accessing the blockchain. Jenny can send this to any institution who then can verify the certificate. If you see in the overall workflow, in addition to the crypto concepts what we have learned throughout, what is new is the Ethereum blockchain. For those who wonder what Ethereum blockchain is and how it fits into the system, let's dive a little deeper into it. Unlike Bitcoin's blockchain, Ethereum blockchain doesn't just track financial transactions but also features a key piece of technology called the smart contract. Smart contracts are simple programs that are written in Solidity and stored on the blockchain. Applications interacting with Ethereum blockchain can access the APIs in the Solidity contract and also listen events from the contract. In this system, each university deploys an Ethereum contract. The contract consists of APIs to issue certificate, constructs required to storing the mappings of students' public key and their certificate hashes, APIs to verify the certificate. Issuing certificate involves updating the contract state by invoking relevant contract APIs to store the mapping of student public key and signed certificate hash. Verification of certificate involves providing certificate hash which needs to be verified along with the owner of that certificate to the contract API, which will return a boolean true or false indicating if that's an authentic certificate belonging to the owner. As simple as that. Now that we have covered the overall system, let's get to the software architecture of the system. We have a web-based front-end which is used by the universities to issue the digital certificates. The requests generated from this web page are directed to a DigiCerts Node.js server. The implementation of the server is as follows. Topmost layer of the stack is the Express.js, which is HTTP server framework. The lowermost layer of the stack is the Web3.js framework, which is responsible for interacting with the Ethereum blockchain. The middle layer, Cert.js, is where the core functionality of the DigiCerts app is written. It handles the requests provided by Express.js and drives the Web3.js for the blockchain interaction. This layer does the functionality of certificate issue described in the workflow and serves a digital certificate with embedded verify functionality. The verify code is a JS code running on the browser, which again uses Web3 API to perform the certificate verification. Enough of words, let's see things in action now.
The command npm install installs the decentralized DigiCert server software and its dependencies on the machine. Now that server software is installed, we use npm start to start the server application. Once the server application is started, it listens on port 3000. Since the server is running on localhost, we type http localhost at port 3000 to connect to the server. This step would be done by the certificate issuing institution. Once the browser is connected to the decentralized DigiCerts server, it responds with a HTTP form for the issuing institution, where the issuing institution can fill details like name, course, date of completion, etc. One key piece of information to note here is the student public key. Each student is uniquely identified with a public key and is used to associate a certificate hash with that student. Right now, these details are entered through a form. In future, this can be modified to be keyed in from student database maintained by the universities. Once the issuer clicks Generate Certificate, an HTTP post request with the form details is sent to the server with the student details, and server does the job of creating the certificate and storing its hash in the blockchain. You can see the logs that indicate the steps done by the server. Computing certificate hash for indicates the certificate hash is being computed for the created certificate. Adding certificate hash to blockchain is the part where the server code invokes the Web3 APIs to add the certificate hash into the Ethereum contract. What follows is logs specific to Ethereum transaction, and finally adding signed transaction to blockchain is the place where we add the signed transaction to the blockchain. We have been using test Ethereum blockchain, which is called Dropston. Through this UI, you can see the transactions on that test network made by a specific address. Note that the generate certificate triggered an Ethereum transaction with an update in the contract state. Contract state is now updated with an additional student public key certificate hash mapping. After the certificate hash has been added to the blockchain by the server, it responds with an HTML page containing the certificate image with embedded functionality to verify that certificate. Upon clicking verify, you can see the steps involved in the certificate verification. The SHA-3 of the local certificate is computed. The hash from blockchain is fetched. We compare the local and blockchain hashes. If that is matching, we are good to go. All done.
With the help of this system, you can now create a record of lifelong learning and achievement from across schools and even employers. You can share your records anywhere, online or directly with a third party. When applying for a job, for instance, gone are the days when you have to pay money and wait for records to be sent. To demonstrate the feasibility of this solution, we have implemented one application of this technology. However, the application of this solution is not just confined to this. It can be scaled even to do HTTPS without certificate authority, which company Namecoin is already trying. But the big question is, will it ever be adopted widely? The ubiquity of the current system suggests that is unlikely, but the real question might be whether or not the current system will be able to survive without modification as its shortcomings become more apparent and more problematic. Well, only time will tell us. With this, we'll take your leave and open this session for questions.